Welcome to Class Time, your daily classroom for CSEC and CAPE students. Today's lesson is CSEC Maths.
I am Brittany Henderson.
And I am Latoya Shariah. Today we'll be looking at probability. We want to determine experimental and theoretical probabilities of simple events. But what's probability, Brittany?
All right, so probability, I think, tells you how likely something is to happen, right? I think it ranges from 0 to 1. Somewhere in between there, so it's a fractional number, decimal, somewhere there.
All right.
All right, so 0, a probability that is 0 is something that is impossible. So, for example, me being reborn, maybe, the probability of me going back into my mother's womb and being reborn is kind of...
Or a dog teaching class time.
Or that too.
All right.
An even chance probability, what would that look like?
Like half a chance of happening, it might happen or it might not happen.
Yeah.
Seeing that I'm clumsy, I'm going to think me falling is an even chance of happening while walking.
Yeah, you could. It's likely that you could fall or you may not fall, right?
Let's hope.
And certain probability, certainty. We know that tomorrow it have to happen. You know that by all.
I'm going to have $1 million in my account.
Girl, big up yourself. Big up, high five. Big up yourself.
Is that certain?
No, maybe not. Because that is, you can or you cannot. I think that is even chance. I think certainty is, I'm certain that tomorrow is December 15 and tomorrow is a Tuesday.
Okay, $1 million in my account, Tuesday. Works.
Girl, keep dreaming. Even chance.
All right.
So, as was stated before, a probability can be expressed as a decimal, as a fraction, and even as a percentage.
Okay. So
let us explain this number line again. So we spoke about it earlier. Impossible, even chance, and certain. Represented as a decimal, as a fraction, and as a percentage. So as impossible as a decimal is?
0.
Fraction?
0.
And percentage?
0%.
All right. Even chance of something happening?
0.5 or 0.5.
Or as a percentage?
Half.
Percentage?
50%.
All right. Certainty. No, I know that this is going to happen. As a decimal?
1.
As a fraction?
1.
And as a percentage?
100.
So 100% that this thing will happen.
Definitely. That $1 million in my account.
Girl, keep dreaming.
All right. So today we're actually talking a bit now about experimental and theoretical probability. And what's the difference between the two? So experimental probability is the actual result of an experiment, as the name states, while theoretical probability is the expected outcome. So you have an idea that this will happen, right? Both probabilities may differ for a given experiment, and we want to talk about that a little. For example, you can conduct an experiment where you flip a coin 100 times. The theoretical probability is 50% head, 50% tails.
So you're telling me that there's an even chance of me getting a head or a tail because it's two-sided?
Two-sided, unless you have a three-sided coin, which I've never heard of. So
never saw that before.
So if you have a coin, you have an even chance of getting the head and an even chance of getting tail. So that's 50-50. However, if you actually conduct the experiment, you may have a case where you got 30% heads and 70% tails, which means that both probabilities were different because our theoretical probability was a half for each option. So half head, half tails, because it's 1 out of 2 choices that gives us our half. And then for tail, it's 1 out of 2 choices. Whilst our experimental probability gave us 3/10 and 7/10 for the probability. So here we're seeing that the theoretical, meaning what was expected, probability and the experimental probability were actually different. All right. So if you were wondering how it is that we came up with those two numbers, this is how we find theoretical or determine theoretical probability. So your numerator will be the number of favorable outcomes. So in the case of the coin, we were looking at the probability of getting the head. So the favorable outcome there would be 1. And then our denominator would be the total number of possible outcomes. Now the coin only has 2 possible outcomes, and so that's how we got 1 out of 2 or a half. Or experimental probability, how do we determine that? So the probability of the event, and in this case, let's say getting the head, would be the number of times an event occurs for the numerator and the denominator, which is the total number of trials. So if I did 10 or the 100 trials, my number of times the event occurred would have been 30. And then the total number of trials would have been 100. And so the probability of getting the head would have been 3/10 or 30/100.
Nice.
All right. But what better way to determine these kinds of probability rather than doing the experiment?
Yeah, so let's get into action. So we're going to carry out a few experiments now to determine the experimental probability and see how that checks out when we look at theory. So we're going to look at what theoretically is supposed to happen, and then we're going to carry out a series of experiments and see exactly what we're going to get, right? If you guys are already at home, you can get your deck of cards, you can get your little die, you can get some cups, and come do the experiments with us.
Right. And you can tell us on Facebook using the hashtag TVJ Class Time.
Yes.
And let us know how your experiment worked out. All right? So first, we are going to be using our cards. So we want to find out what is the probability of getting a heart from a deck of cards. And we know that there are quite a number of hearts in a deck of cards. So we don't want to know which particular heart. It's not heart of diamonds. Not heart of 10 of hearts, but any heart.
Just a heart.
Right? Just a heart. And so the first thing we want to do is to determine our theoretical probability before we do our experiment, to determine our experimental probability. Now, as we stated, you can determine the theoretical probability by numerator would be the number of favorable outcomes. So, want to get a heart from a deck of cards. Brittany, how much favorable outcomes do we have there?
All right. So in this case, in the deck of cards, I think we have 13 hearts.
All right, let's count. Start from ace. Ace, 2, 3.
Girl, we have 4 suits, don't? We have spade, diamond, hearts,
clubs,
and hearts, right?
Right,
4.
right.
And the card deck have what? 52, right?
52.
All right. And you say no. All right. Ace and go. Ace, queen, jack, king. Ace, queen, jack, king.
Let's start.
10, 9, 8, 7, 6, 5, 4.
All right, you use your 10 fingers, I use my.
All right. Come again.
All right, come again.
Ace, queen, jack, 10, 9, 8, 7, 6, 5, 4.
3, 2, and you never say king.
All right.
13.
Oh, yes. Okay.
13.
So we have 13 hearts.
All right. So that means that our numerator would be 13. And then the total number of cards, which is the total possible outcome,
would 52.
Be 52, because there are 52 cards in the deck. All right. Excluding the jokers, that is. So this deck does not include our jokers. And if we were to simplify 13/52, we would get 1/4. And so the probability of getting a heart or any of the other suits is 1/4. And we are going to do some tries and see what the experimental probability would be. So here are the instructions at home. So get your cards, get mommy, get daddy, get your sister, get grandma, and try this experiment, right? So you're going to draw a card from the deck, record the suit, and put the card back in the deck. You have to put the card back in the deck, because if you don't put back the card, then you're now changing the total number of possible outcomes, right, Brittany?
Yes.
And you want to continue until you have drawn and replaced 4 cards. So, all right, so Brittany is going to record. I'm going to shuffle. I wonder if one of our cameramen wants to come and draw. Clive, you want to come and draw a card? All right. Come on, Brittany. So you're going to take 1 card. What one?
I'm trying. Okay.
All right, and you get
I got a diamond.
Okay, so you're going to record your diamond. So we got 1 diamond so far. Shuffle. All right. Pull another one.
Okay, better. Oh, no, you're not shuffling
I'm
the
a
card,
magician.
girl.
Same diamond. Or maybe you mark the card, Brittany. All right, ready. So that's 2 out of 4 draws.
Big money. I want
Big
a heart.
money, all right?
Mm-hmm. Is a heart we want, don't?
Right.
All right, let me come to the front. Maybe the heart is closer to the... Oh, I got a heart.
All right, so that's 1 heart. 1 more draw. Okay, all right, here we go. Ready?
Okay, heart.
Big
Again,
money.
I'm coming to the front because,
big money.
Oh, Lord. Guys.
5 of clubs.
I got a...
All right. Okay, so let's see what our experimental probability is. So we had 4 draws, and based on the recording on the board, I'm seeing here where we have heart to be 1/4, diamond to be 2/4, and we can simplify that to a half. And then we have clubs 1/4. Now, based on our theoretical probability, we knew that we had 1/4 of a chance of getting each suit. But in actuality, let's see what we have here. So heart was 1/4, so our experiment is actually matching to our theoretical there for hearts. Diamond, that was a half or 2/4. But for the theoretical, it was 1/4, so that's a little bit different. And for clubs, it was 1/4, which is in keeping with our theoretical. And so we're going to conduct another experiment with the cards. Now, what I've done is to separate the suits, and I have clubs in my hand. And now I want to see how good you are, Brittany. I want to see if you can get the ace of spade. So first we want to determine now what is the theoretical probability of getting the ace of spade. We say that, which is represented as a fraction in this case. And our numerator will be the favorable outcome, the number of favorable outcome.
Okay. How many aces there in ace of spade? 1?
1, right?
Okay. 1.
And then the total number of possible outcomes for the suit of spades.
13 spades in a deck, don't?
Yes.
Okay. 13. So that's 1/13.
1/13, right? All right. So let's see.
Okay.
So I wanted to put other as the other option. And I'm going to give you 3 tries.
Okay.
I'm going to give you 3 tries, and we're going to see if you can get ace of spade. Let's go.
Okay, so I'm going to start from the top, and then I'm going to go in the middle. Okay, top, let's see. That was a fail. So I got 6 of clubs.
6 of clubs.
So that's 1 for
Spade.
other. Oh, my bad. 6 of spade. I'm sorry.
All right. Remember, you can try at home and tag TVJ on Instagram and let us know what was your experiment like. All right.
All right, let me go to the middle now. Yeah, middle it. Let's see.
All right.
Okay. Guys. Nine of spades. What is going on? No, I don't understand.
I don't think gambling is in your future. It's not. All right, final try.
I would like, the ace of spade. Ace of spade.
All right, final try. Let's go.
Ace of spade. I got it. Ace of spade. So.
All right.
Third time's the charm.
Third time's the charm.
Here you go.
All right. So what is our results telling us, Brittany?
So the experimental probability, so we got ace of spade just one time, so that's 1/13. And we got other spades twice. So that would have been 2 of 13. And so it looks like it's adding up here, right? So the probability of me actually getting, theoretically, an ace of spade was 1/13. Based on my experiment, it is still 1/13, right? However, we also got other twice before that, which is 2/13, which if we look at the theory...
And there were two different numbers too.
There were two different numbers,
right?
yes.
So if we were pulling those numbers, then the probability would still lie. Because to get any of the number in the suit would have been 1/13. Right.
So this experiment kind of,
All right. I want to give you one more try, and I'm going to put back all the cards together, and I want to know, see if you can still get the ace of spade. Yeah, man. Yeah, man. But would our theoretical probability now change?
No, we have how many cards again? We have...
so I now have the entire pack.
So that's 52.
Right?
So we have 52 cards, and there are... What did you ask me for again? The ace of spades?
Yes.
There's still only one ace of spade, though.
Right?
Oh, boy. 1 out of 52 cards.
But I have a question. Do you have a greater chance or a lesser chance of getting the ace of spade?
Well, if before I had 13 cards and it took me 3 tries, I know I have 52 cards. Guys, what do you think at home? I think my chance kind of look darkish. Darkish.
Okay.
All right, let's try.
All right, let's go.
How many times are you going to give me?
How many tries do you want?
I'd like 3 because it seems to be the charm for me. The third one?
Okay. All right, no problem.
All right, let's try.
So our theoretical probability is
It's 1 out of 52, and I got an other, so I got 9 of spades.
Okay. All right.
Oh, my bad.
Put it
Sorry.
back. Remember, you have to put it back. All right. Try number 2.
Okay, let's go for the top. I tell you, what you do with the cards? What? Guys, 9 of spades again. What's going on? There you go.
All right. Final try. Big money.
Not even if that can help me now.
All right. Here we go.
All right, let's try down the back. Oh, no. Okay, guys. So the 9s are working for me, so I can pull a 9. I have 9 of diamonds here, but still...
No ace of spade.
No ace of spade. What's going on? Here you go.
So that means that our experimental probability in this case, is it matching to our theoretical probability?
Well, in this case, no, No.
And that's fine, because sometimes your theoretical probability won't match your experimental probability. And that's the point we want to drive home. So ensure, if you are doing your experiment at home, and you can do your experiment with anything, you can get a bag of snacks, ask somebody to pull from the bag, and determine the theoretical and experimental probability and share it with us on Facebook or Instagram. All right, so Experiment number 2, we're going to be using a die, one die. And we want to find out what is the probability of getting a 1 when you roll an unbiased die. So I didn't pad up any particular side of the die. It's a very fair die. So I have a fair chance of getting any of the 6 faces when I roll this die. And the first thing we want to determine is our
theoretical probability.
All right. And what is that?
All right, so you just said it. We have our die here has 6 faces. So the total number of possible outcomes is 6. And the number of favorable outcomes, so in this case, I want to get a 1. So that's really just 1. So in this case, that's 1/6. So my theoretical probability of getting a 1 when, or of Latoya getting a 1 when she rolls the die, it's 1/6.
Okay. All right. And by that, we can also see that the theoretical probability of getting any of the faces, any of the numbers, would be 1/6. So I have a fair chance of getting any of the numbers on the die. All right. So here we go.
Roll away.
Get your die at home and try. Wow. 3. So I'm going to give myself 6 tries.
Okay.
4. Still have 4 more chances. Don't feel, 1. All right, I have 3 more. 6. 4. 1. How many tries is that? That's 6 now.
Yes.
All right. So of 6 rolls, what is our theoretical probability?
Oh,
Experimental probability, sorry.
all right, so for the outcome, which is 1, which is really what we wanted to get, we got 1 twice for the 6 rolls. So it would have been 2/6. We got 2, no time at all. That's 0. We got 3 once. We got 4 twice. And we got 5 not one time, and 6 just once. So
All
let
right.
us look at the comparison between the experiment that we carried out and what it says theoretically that we should have gotten. So here on your screens, you'll see the theory. So theoretically, for each one of the outcomes, we should have gotten 1/6 theoretical probability, right? And in this particular case, we're looking at the outcome of getting a 1, and boy, them look like them kind of differ here. So it is actually experimentally we got 2/6, and theoretically we would have gotten 1/6 chance of getting a 1. Right, Latoya?
Yes.
So we're seeing almost everything, a few things adding up and a few things a little bit different. Huh?
Only the 3 and the 6 matched theoretically. The 1, 2, 4, and 5 were different, and that's fine. We just wanted to understand that there's a theory, and when you experiment, the theory might differ from the experiment, right? All
That
right.
is correct.
Brittany, I want to see now what is my chance of getting an even number when I roll
Even
the
number?
die. Yes, man, even number.
So what are even numbers again?
Numbers that are divisible by 2 without leaving a remainder.
All right, so even numbers. All right, let's
Yes.
go, guys. So at home, our even numbers would be what? 2, 4, and 6. So based on this die, those are the only even numbers that we have, 2, 4, and 6. So we're looking at the likelihood of getting a 2, a 4, or 6, right?
Yes.
All right, awesome. Guys, I hope you have your die out, I hope you're doing this with us, right? All right. So what is our theoretical probability, Latoya, of getting a 2, 4, or 6?
All right, so there are 3 even numbers, and there are 6 options.
True. So that's 3/6. It looks kind of like
1/3. Well, half.
3/6, a half. So it looks like a half. All right. Hold on a little bit, Let's erase this real fast. All right, good. We're ready again. All right, so Latoya is going to go ahead and carry out this experiment again. Guys, get out your die and roll with us.
Not close die, no, This die, right?
All right.
Six.
Awesome.
So how many rolls should I do?
Do 6 again, no? Do 6 again.
All right. 1.
Okay.
Woo, 3. 4. 1. How many is that? 5? One more?
One more.
6.
All right, so guys, here we have our theoretical probability, which was 3/6 or a half. Now let's check and see if the experiment matches up to what we said theoretically. All right, let's are you ready?
Yes.
All right, so we got a 1 how many times?
2 times.
Twice, so it's 2/6. We didn't get any 2s this time, so we got 3 and 4 just 1 time, so that's 1/6 each. And we got 6.
2 times.
2 times.
No 5.
No 5. No. What were we trying to do again?
Get an even number.
Let us look at the theory and what it is here. So the theory is 3/6, and based on this table, is that so?
How many even numbers did we get? I'm seeing
We got
3, 6.
yes.
So we got the theoretical probability is indeed matching up with the experimental probability. But I have a question, Brittany. From the experiment we did just now, what's the theoretical probability of getting a prime number?
Oh Lord. First she take me to even numbers. Now she gone to prime numbers.
Come on, math is continuous and it's all together. It's going to come together. It's not different.
All right, Latoya,
Yeah,
remind
man.
me again, what are prime numbers?
So a prime number has only 2 factors, 1 and itself.
All right, so from this, let us say 2, yes, 2, 5,
5,
3.
3,
That's it, no?
right?
So 2, 5, and 3.
Right.
All right.
So that means that our probability for getting
A prime
a
number.
prime number is the same as getting an even number.
It looks like that,
All right, so let's see then from our experiment if the experimental probability and the theoretical probability is the same or different. So how many of the prime numbers did we get and what's that fraction?
Well, guys, based on our experiment, you check it with me. I didn't get any 2s, right? I got 3 once and I got no 5s. So from this experiment, it's 1/6. And you said that theoretically it should be 3/6. So in this case, guys, it didn't add up. So the experimental and theoretical probabilities differed. And again, let's emphasize that. It's okay if it's not the same,
Yes.
okay? All right.
All right, here's the fun activity now. And I want us both to do this one.
Oh, Lord.
So we're going to do a cup flipping activity. You know that drinking game, but we're not drinking. No, we're not promoting that. None at all. All right. So this is what we're going to do. We want to know what is the probability of the cup landing on bottom up. So we want the base of the cup to be upward. So first we have to determine what are the possible outcomes when we flip a cup.
All right, so it can land on the base.
The base,
It can land on the top.
the opening,
And it can land on the side too, don't
on the side.
Okay.
Right. And we want to know what's the probability of it landing base up, bottom up.
One out of 3 possible outcomes. Yes.
All right, one third. And by nature of that, the probability of get the cup landing on any of the options there would be 1/3, yes?
That would be correct.
All right, so we're going to do 6 times. I'll do 3 and you do 3.
Okay, that can work. Because,
Okay.
you know.
And so one, I go, then you go.
Okay.
All right, so here we go. And don't use your mother glass cup, you know. Use the plastic ones, right? So I'm going to flip, and let's see.
Okay, go flip away.
Oh! Proud of myself. All right, your turn.
Oh, all right.
Let's see.
Okay, let's try this. Guys, don't laugh after me if it don't really work, you know? All right. Side.
Aww. I'm not going to boast and say I'm a winner or anything. I'm just...
You just get one lucky flip. Look at that.
You see, that's why I must not be boastful.
Yes. All right. All right, all right, all right. Come, guys. Hope... Oh, Lord.
Side.
This side seems to be my favorite thing to land on.
All right. My time.
Okay.
Alrighty.
All right, and it's me again. Let's go. Okay, cup. Let me even clear the way. Ready? Let's...
Does that really count though?
It counts. The computer is in the way. It counts. Guys, it counts.
Look at that. It's actually, I don't think that, fine.
Thank you. Thank you. Thank you. I get a little, like a shine. Yes.
I think we should go 3 more times. I'm going to win. Ready, let's go. My turn, ready.
Okay.
This cup though.
La-da-dee. Let me even put it down here, guys, because I don't want anything to obstruct my flipping.
Oh my days! I don't like this. I don't like this. I really don't like this. Okay. I don't like this.
Okay. My last time? My last one? Again, nothing to obstruct. Okay, ready?
All right, sit here now. Winnings. Winnings. Wow. Okay. Okay. How many times would we have gone in total?
12.
All right, so we did 12 tries. So let's see.
All right, so for landing on the base, we got 5 12s. For landing on the side, for the cup landing on the side, we got 7 12s. Okay. Now, that time, I forget what the question was.
What's the probability, the probability of landing on the base up? Base up.
Okay, so now we did it, we flipped our cups 12 times.
Right.
So the probability of landing base up out of 12 flips would have been what?
1/4.
Okay. And this is for 12.
Right.
For 12 flips. Right?
Because we have 12 flips and you should have an even number of getting the cup landing on any of the sides.
3 sides.
Right.
Good.
So from the 12 flips divided by 3, then we'll get 4. So it would be.
All right, so let's look at our table, guys. Our table for landing on the base was 5 12s.
Base up.
Base up. Top up. Top up, that's it. Top up was 0.
Right.
Landing on the side was 7 12s, right?
Right.
So based on this, is our theoretical probability matching back to our experimental probability?
Nope.
But is that a problem?
Nope.
So sometimes that happens. So there are times when your theoretical probability will not match up to your experimental probability. So guys, if you tried the experiment at home with us, thank you very much. I hope you had fun. I had fun. I never knew I could flip a cup, and I'm happy. I was flipping.
All right, so just to quickly recap, experimental probability is the actual result of an experiment, while theoretical probability is the expected outcome probability lies from 0 to 1.